I'll talk about the earliest modern human today. Um, and this was a really interesting early part of Richard's career. The structure of the talk, I'll talk a bit about the discovery, initial analysis, new dates from the initial finds and controversy that resulted. Then a new research project that was led by John Fleagle, dates and geology, and new fossils and analysis. And so the initial discovery was made as part of this international OMO research project, which was designed to include Ethiopian, Kenyan, French, and American scientists as a very sort of international enterprise. And Richard Leakey led the Kenyan team. And so Richard Leakey's camp is, let me see if I can find it, it's just in here, right along the Omo River. There's the airstrip that they cut. And there's a closer up view of it. It was a very difficult place to get to, I think, as you heard yesterday. And early in the season, Kamoya Kameu found pieces of Omo 1 at a site that became known as KHS for Kamoya's hominin site. And some of the skeleton was actually excavated in situ. And very soon after that, Paul Abel found Omo 2 on the other side of the river. And so here's a photograph from the time of Richard and Kamoya with his, go back here. Kamoya with his back turned there, excavating the site in situ. And there's Paul Abel working on Omo 2 to piece it back together in the field. The Omo expedition was also kind of a training ground for a lot of other very talented researchers, and this is Frank Brown working in the exposures there, and he was instrumental in working on a lot of the initial stratigraphy. Okay, so what did the initial analysis of these two hominin skulls show? This was led by Michael Day in 1969, and Day argued that Omo 1, which is over here, was anatomically modern. It has a point of highest breadth high up on the cranium, a relatively contracted cranial base, a very high and rounded occipital bone, and a very high cranial vault. Omo 2, however, he argued, was not modern. It has a very angled occipital that looks fairly primitive in that regard. But both of them had modern-sized brains, and in fact, they're actually above average for modern people today in terms of brain size. Omo 1 also had a chin, and this still marks really the first appearance of a very distinct chin in the fossil record. And soon after that, Chris Stringer did his dissertation with a multivariate analysis among crania. And his results are shown here with lines connecting specimens that were particularly close together. And so these lines that connect things indicate close relationships. Omo 1 is down there with relationships to a fossil from Nigeria at the beginning of the Holocene, Iwo-Oleru, and then a variety of more ancient humans, as well as Skull 5 and Upper Paleolithic folks. And so that really emphasized a lot of its more modern character. Omo 2 was down here with one relationship to Iwo-Oleru, but also with a kind of perhaps striking resemblance to the Solo Homo erectus crania from Indonesia. And so this really tended to emphasize its less modern character. Interestingly, Jebel Irhoud is right there with a relationship to Skull 5, but not so much to Upper Paleolithic modern humans or even to Omo 1. And so this is probably a pretty good representation of where still things stand today. Okay, the dates also provided a source of some controversy. And part of the reason for this is what people expected to find. In the 1960s, the view was that modern humans appeared around 50,000 years ago, and they came from a transitional population like Skul and Kafsa in the Middle East. And this is a thing from a Time Life version with Skul 5 on the cover with its distinct chin and a variety of other somewhat more primitive characteristics. And the dates that came out for the Omo deposits really challenged this conclusion And as a result, there was a lot of skepticism initially about them. Nonetheless, the geology showed from early on that in fact they seemed to be pretty old. And Richard Leakey wrote that OMO-1 alone was associated with a small number of stone artifacts and some animal bone debris. An excavation of the KHS site yielded some material in situ and established the provenience of the OMO-1 skeleton in terms of stratigraphy. So it was basically part of member 1 in the Kabish Formation. And Butzer, in describing it, said that OMO-1 was found at a minor disconformity separating beds D and E of member 1. And there was actually this geological sketch that was made from the excavations in situ, showing exactly where OMO-1 was found, and some of it is directly embedded in member 1. And so the initial set of dates they got back from this included radiocarbon from up here in member 3 as 37,000 years ago or more. And in the 1960s, this was essentially an infinite date, or could be. And a few months later, they attained a uranium-thorium date of 130,000 years ago on shells. These dates basically were met with a lot of skepticism. And so Walpoff, writing in 1989, described basically what many people might have thought at that time, that the OMO radiometric dates have been continuously disputed since first publication because the radiocarbon determinations based on shells are notoriously inaccurate. I'm not sure that's right. And uranium-thorium dates are problematic. And various faunal and stratigraphic dates have been suggested as replacements. And according to these ages, the 3 fossils range from 40,000 to 130,000. And he said which of the various date estimates may be correct cannot be established, and there's not particularly a reason to accept any of them as valid. There was also the kind of problem of the difference in morphology between OMO-1 and 2, and Richard Klein, 10 years later in 1999, wrote a stark morphological contrast between OMO-Kabish 1 and 2 may mean that one or both were intrusive into the stratigraphic unit, and that OMO-1 may be much more recent. And so this was one of the other potential criticisms that was raised and kind of presented in the literature, repeated often in the literature about it. All right. Okay, so the new research project really began at the instigation of Zelalem Assefa, who pointed out that the OMO-Kabish fossils were really important for debates about modern human origins, and that no one had really been back to the Kabish in 30 years. And so John Fleagle was able to assemble a team of himself, Zelalem, Solomon Yerga from Addis Ababa, John Shea, Frank Brown, Craig Fleagle, and Ian McDougall to try to tackle some of these problems. Their goal was to try to establish a better chronometry for the formation using tephrostratigraphy especially, document fauna throughout it, document archaeological record of the Kabish Formation, clarify stratigraphic position and sedimentological context for the hominins, and the kind of pipe dream in all of it was to try to collect more hominin material. Access to the site remained very difficult. This was a very hard place to get to in the 1960s, and it has not gotten much easier. There were still major problems involved in crossing the Omo River. And one of the initial things that was done is to try to revisit these old hominin sites. Site 1 was located pretty much exactly where the maps showed. Site 2 was a bit more problematic, and actually a map by Paul Abel, where he had found the actual hominin, shows it in a somewhat different location than the published map by Butzer. And in fact, Paul's map was correct. And so this is a 1967 photograph of Paul and I think Richard down here looking at the spot where Omo 2 was found. This is the site back in 2001 with Frank Brown. This is the 1967 excavation of KHS. And this is the site in 2001 when it was rediscovered. There were hominin remains sitting right on the surface, so there were more of these fossils right there. And this is John Shea at a kind of a expanded and version of the find or the find spot at KHS. So the work there actually resulted in new radiometric dates, so tephra that were dated and published in Nature. And the basic outcome of this was that a 200,000-year tuff was right below OMO 1, and a 100,000-year tuff was in member 3, middle of member 3, much above it in the stratigraphic succession. And then there were Holocene dates for member 4 at the very top. Another piece of this came from the way in which sediment accumulates from erosion in the Ethiopian highlands. And it turns out that there is a huge deposit of sediment in the Mediterranean, as well as some sediment from this that drifts farther afield. And this has actually been cored. There are dark layers within the sediment that are high in organic matter called sapropels. And these sapropels basically are recording sediment that comes down the Nile River, but sediment goes the other way as well into the Turkana Basin from the same sort of precipitation events. And basically, it turns out that the sapropel record comes in distinct pulses, in which sapropel 7 almost certainly corresponds to member 1 with a substantial amount of deposition relatively quickly. Sapropel 4 is almost certainly member 3, and sapropel 1 would be member 4. There were some additional papers that came out since then. One of them was by Aubert and colleagues looking at uranium series dating of a whole bunch of sampling of a tiny piece of the cranial vault of OMO 1. And this provides a minimum age for this fossil of 155 to 180,000, and that would confirm a fairly ancient origin for it and not really correspond to a modern intrusion. There was also a paper by Vidal and colleagues that also suggests the dates may be even older based on various volcanic tuff correlations. Okay, so let's turn now to the new fossils that John and his colleagues were able to find. So the old fossils are represented here, minus some vertebrae and other small fragments. And on the right are the new fossils that are picked out with the arrows as shown. And so I'll talk a teeny bit about some of these as we go here. So there was a talus and some toe bones. Another part of the femur found in 2001 that fits kind of perfectly on the part that was found in 1967. There is the Homo kabish innominate on the right, which was an interesting bone. It's fantastic to get. It has a large acetabulum that would suggest a male sex, but also a pre-auricular sulcus and sort of an intermediate form of the sciatic notch. Ashley Hammond and colleagues in 2017 took a very careful look at this. They concluded it was female. It was most similar to recent Sudanese people, but considerably bigger. Okay, so the auricular sulcus seems to indicate that OMO 1 was a young adult, 20 to 30 years in age. From the humerus, about the bottom half is preserved, and if you go up to the bottom of the deltoid tuberosity, double that, which usually works for modern humans, you end up with a pretty long humerus of about, which would estimate 178 to 182 centimeters. But the first metatarsal you can also use to estimate stature and produces a much lower estimate of stature. And then the predicted femoral head diameter and mass of this individual would be about 70 kilograms, which is actually pretty large for a contemporary modern human. There's also some other curious traits. One of them is in the base of the first metacarpal here with a fairly dorsopalmarly flat surface. And this is something that is often seen as primitive. It's a feature that's common in Neanderthals, and we're not sure how much earlier that might have gone. There's also some very modern traits. This one indicates a pretty high coronoid process. And this is sort of a new thing with modern humans. Fairly platykinemic tibia, which is pretty common, with weak muscle markings. And interestingly, in the right elbow, the right ulna, and also distal humerus, there's signs of arthritic changes with a lot of arthritic lipping around the joint surface. And for a young individual, that's almost always an indication of injury of that joint, either through overuse or sort of sudden traumatic events. There's fairly low bilateral asymmetry that's common in females throughout the Paleolithic record, as well as thick cortical bone, which is also a fairly common trait. And so Omo 1 is basically modern in its anatomy, but it retains some ancestral or unusual characteristics. And in fact, as you go farther back in time to this period or even beyond, this is very common. So almost all of the individuals from Skul and Kafsa are very similar in retaining some unusual or archaic features. Okay, so the denouement of this was that Richard Leakey stopped working in the Omo Kabish at the end of the 1967 field season and never came back. And one of the reasons for this was that as the various groups would gather and compare their fossils, there was a lot of excitement about the older fossils that were coming out of the French and American excavations. There were also a lot of fauna that were coming out of these excavations. And in comparison, the Kabish Formation has an awful lot of sediment with relatively sparse fossils in it. As you've heard, as on a flight on the way back to the camp, Richard was diverted over this area, and looking down, there was an awful lot of sediments that looked like the Shungura Formation and basically fossil-rich sort of things. He borrowed, the helicopter came back. There were fossils all over the ground at Kubifora and Illirit, and the next year they came back and found fossil hominins right away. And so with that, Richard's attention turned to Kubifora and never really returned to the Omo, although these fossils remain terribly important today. Okay, so there's Richard and Paul. And again, John's work at Omo Kabish has been supported by National Science Foundation, the Leakey Foundation, National Geographic Society, Australian National University, and the SSHRC. So thank you very much.